Okay, this lesson focuses on identifying and naming examples of aldehydes and ketones from these first few sections of chapter 17. And later we'll talk about some important reactions of these. Aldehydes focus on this carbonyl group. That's a carbon-oxygen double bond. And as you can see, it forms this trigonal planar type structure, which is oftentimes how it's drawn on paper, and it's customary to show that carbonyl group kind of pointing directly up from that carbon, although it can in principle point in any direction. What makes it an aldehyde is if one of these other two bonds is a hydrogen. The fourth location can be another hydrogen, or it can be methyl, ethyl, propyl, whatever. As long as you have this sequence of atoms, a carbon that is single bond to hydrogen, double bond to oxygen, you've got an aldehyde. All right. Here are the simplest cases of those. You can see each of their official names ends in AL. That's the official IUPAC suffix for an aldehyde. Just like the word aldehyde begins in AL, specific examples of them end in AL. So we get methanal, ethanal, propanal, butanal, pentanal, hexanal, that kind of thing. And typically they are drawn to highlight that carbonyl group, and sometimes to highlight the fact that there is, again, this hydrogen that has to be attached. So that aldehyde group has to be at one end of the chain or the other. I guess if we were numbering carbons, we would start with the carbonyl carbon being number 1 there. But these don't need names, because if they are aldehydes, then that aldehyde group would have to be drawn at one end or the other. This condensed formula is sometimes what you see in textbooks. That's kind of an old-fashioned way to draw it. I guess we could assume that that CHO is not just single bonds, that it's not an alcohol, for example, because there would not be enough hydrogens to make that correspond to an alcohol. Aldehydes can be created from the corresponding alcohol, and in each case it involves gaining back two hydrogens that the aldehydes don't have. These names in red are some of the more common names, not systematic, but ones that these are known by, especially these simple cases. You've heard of formaldehyde. That's the same thing as methanal. That's the simplest of all aldehydes. Acetaldehyde is an older name for ethanal, propionaldehyde, and then butyraldehyde there. But you want to know and be able to recognize and draw these if you are given their IUPAC names, although certainly these names in red show up a good bit as well. Once you get beyond 5 carbons, they are generally known by their IUPAC names. So as we've done before, if you can name things with up to 10 carbons in a row, like decanal, then you'll be in good shape as far as that goes. And there's certainly more examples of naming in the textbook there. Here's some aldehydes that are interesting. They oftentimes have very pleasant odors, sometimes not so pleasant, but they are very distinctive in any case. A lot of perfumes and flowers, things like that, have natural aldehyde aromas to them. You can see this nickname of cinnamaldehyde kind of gives it away, as this being the flavor of cinnamon. It's an alkene as well as being an aldehyde. Vanillin here, you can see several oxygens there. There's the aldehyde group here on the right. It's also an alcohol. This grouping down here makes it an ether, where you have an oxygen that is making single bonds to 2 different carbons. But both of these are generally classified in terms of them being an aldehyde compound. Okay, that's the aldehyde story. Ketones, very different name, but a lot of similarity in structure. Ketones also focus on this carbonyl group, but as you can see, to make it a ketone, you'd have to have carbons on either side of that. That's what distinguishes a ketone from an aldehyde. In an aldehyde, the carbonyl can be like at the end of a chain. Ketones, that carbonyl has to be somewhere in the interior. So the simplest case is a 3-carbon aldehyde, a 3-carbon ketone, like what you see here. And it's the first one on this slide as well. Propanone is the official name. ONE is the official suffix, so their IUPAC names all reflect that. We're still counting carbons and otherwise using much of what we've been using for naming compounds. Acetone is certainly by far a more common way to refer to propanone, so that's an alternate name worth knowing. You can see why butanone might be called ethyl methyl ketone, because there is a methyl group on one side of the carbonyl, ethyl on the other. That is sometimes used. With these systematic names, we need numbers once we get past 5 carbons or more. So 2-pentanone is distinguished from 3-pentanone by the location of that carbonyl carbon. And here are just a couple of examples of some interesting ketones. These have a lot of carbons in them, but the oxygen is kind of highlighted with that double bond so that we can identify these as being ketones. Ketones don't have to be parts of chains, they can also be parts of ring compounds. And these are 2 examples whose odors are familiar. Camphor has a very distinctive odor. So just like aldehydes, ketones are oftentimes identified by our nose. It's just we can't use our nose to determine exactly what that structure is. This one at the bottom, by the way, this is I think a 15-membered ring, and that's a way to draw it so that you could count carbons. If we were numbering, we'd start where that carbonyl group is and kind of go around clockwise. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that might have a name of 3-methyl cyclopentadecanone. Muscone is its more common name. As you can see, it gets its name from its source as well. So, like I say, more examples of structures and names for aldehydes and ketones for you to practice on from the textbook.